Good afternoon and welcome everybody to NASA's Kennedy Space Center in Florida. We wanted to take this opportunity now that the calendar has turned to 2013 to give you an update on the status of NASA's Commercial Crew Program, reviewing the accomplishments of 2012 and also providing a look ahead to what's to come in 2013. We've assembled a panel of experts here to provide this update today, and after they give you an update, we'll be happy to take questions from Kennedy Space Center as well as the Johnson Space Center phone bridge, and on Twitter with the hashtag AskNASA. So we'll go ahead and get things underway. I'd like to introduce our panel. To my left, Ed Mango, NASA's Commercial Crew Program Manager. And to Ed's left, Phil McAllister, NASA Commercial Spaceflight Development Director. Next is Rob Meyerson, Blue Origin President and Program Manager. John Mulholland, the Boeing Company Commercial Program Space Exploration Vice President and Program Manager. Mark Sarangelo, Sierra Nevada Corporation Vice President and Space Systems Chairman. And Garrett Reisman, SpaceX Commercial Crew Project Manager. Thank you all for joining us, and we'll get underway with Mr. Mango.
Hi, good afternoon, everyone, and thank you for taking the opportunity to let us tell you about our commercial crew activities over the last year and what we'll be doing in the future. See, we have a few things we do want to talk about. We want to update you on where the program is at today in our commercial crew program. Phil is going to be doing a lot of that. Also, we asked all the partners to come and join us today to talk about what they have accomplished in 2012. It has been an unbelievable year for the commercial crew program, and what they expect to accomplish in 2013 as we continue to progress towards human spaceflight transportation from the United States. And then I'll come back and talk about a new initiative that is going to be kicking off here in a few weeks called the Certification Products Contract. We awarded that back in December, and we'll be picking that up here in a few weeks. I'll talk about that. And I'll also talk about our planning for our final development and certification effort. So first, I'll turn it over to Phil, and he can talk about where we're at as an overall initiative.
Okay. Thanks, Ed. It's good to be back in Florida, and I'm going to be talking mostly about sort of the strategic aspect of our partnership. The partners down to my left, they're going to be talking to you more tactically about the things specifically that happened on their technical programs, and I'm sure that's what you're most interested in. But partnerships are very difficult. They're even difficult when you have two private sector entities, but in this case we have a public-private partnership, which even makes the challenges even greater in some cases. So NASA has put in place several strategies to ensure, or to at least help ensure, that the partnership would be successful. And I want to touch on several of those. Before I do want to stress the goal of the program. Everything kind of flows from that, so almost all of my presentations start with the goal, which for NASA is to facilitate the development of a crew transportation system capable of flying to low Earth orbit and to the International Space Station for a variety of customers. So we aren't doing the development, we are facilitating that development, and that's where the partnership comes into place, because NASA has some unique capabilities to help, and the partners bring their unique capabilities, and through the combination we hope to do this very quickly, very cost effectively, and very safely. So the aspects of the partnership that I'm going to touch on very quickly so we can get to the good stuff are the 7 items you see listed: financial investments, the quarterly reviews and milestones, the partner integration teams, technical interchange meetings, reimbursable Space Act agreements, data sharing, and requirements application. So let's go to the next slide. Obviously, the financial investment is the thing that gets the most attention. And the money is critical, obviously. To date, through four different activities, we have awarded approximately $1.5 billion to help get us to a U.S. commercial crew transportation system. Not all of this has been paid out. As you can see, a good portion of that is in the ICAP awards, which are going on for about another year and some change. And most recently, you can see we made a small award for the certification products contract. That's a key one that Ed is going to talk about there. But through these series of investments, quite a lot of money to start off with. Still got some more to go, but this represents a pretty sizable investment that we hope will will enable our partners to bring these to bear more quickly. So the next area of the partnership is obviously the milestones. Next slide. The milestones are the formal mechanisms in the Space Act agreements themselves that allow NASA to assess our partner progress. You do not need to read the graphic. That's really just a representation of the schedule for the next year and a half. And you can see there's a lot of tick marks. You obviously don't need to read the tick marks, but there's a lot of them. Those tick marks represent either a milestone or a quarterly review. And the milestones are key because that's where the money gets paid out, right? These agreements, they're not grants, they are not loans, they are pay for performance milestones. So the partners only get paid when they show demonstrative progress towards developing their crew transportation system. And that's what's important for us. So this is a key area where the milestones allow us to ensure that the partners are making good progress, are making good use of our money, and that is the formal mechanism by which they are paid. In addition, we also have quarterly reviews, and that's more of a management activity that allows us and the Commercial Crew Program Management team to assess, again, the partnership as a whole. It's great to get these individual milestones and see how they're going, but we need to take care and feed the partnership, and that's what the quarterlies allow us to do. We get together every 3 months, talk about their overall progress, has there been any changes, any problems that have cropped up, and allow us to really talk about the overall effort for each one of our partners. So that turns out to be a good activity as well. Next slide. You know, a lot of people, I believe, think partnerships are really just about mission statements and core competencies. They really aren't. They're really about relationships. And the partner integration teams are where those relationships really take hold. They're the face of the agreements. They are the ones sort of on the ground floor with our partners, working day to day on their efforts. We have part of the partner integration teams represent a multitude of disciplines. So that's what you see in the right-hand graphic. They represent engineering, health and medical, safety, ground system, launch systems, crew office. All those capabilities are available and accessible to the partners and on a more regular basis. They don't provide direction, but they are available to provide lessons learned and history and experience with our partners on a day-to-day basis. And the partners help us gain the insight that NASA feels it needs in order to assess how the partners are really doing. So they're kind of an independent check for us to really understand the nature of the system, how well these tests are being performed, how well our partners are progressing. So it's really a two-way street that the partners the partner integration teams help our companies, but also help NASA. Next slide. You know, when we need to do a deep dive on certain technical areas or issues, that's where we use technical interchange meetings. And these have turned out to be very productive, very positive aspects of the partnership. It's always good to exchange information on a day-to-day basis, but some of these issues that crop up can be very challenging, complicated, and for those you might want to get a bunch of people together. The partners come with their people. NASA brings some technical experts that are outside of the regular PIT teams, but may have specific information into a specific subject matter, and you can really make a lot of progress in 1 or 2 days. We have had dozens of these TIMs with our various partners, and they've covered everything from propulsion to avionics to ground systems, just about anything that is really can be difficult. We've probably had a TIM on, or maybe multiple TIMs on. So that's turned out to be, again, a good positive face-to-face exchange of information. Next slide. Reimbursable Space Act agreements, this is a real win-win in my opinion, where NASA has unique, underutilized infrastructure, whether that be facilities or personnel or equipment. We can make them available to our partners on a cost reimbursable basis. So the partners actually reimburse us for their direct costs associated with using our equipment. Maybe it's a test stand, maybe it's a wind tunnel or something like that, or maybe it's even our technology or our people who have a unique expertise and may not be fully utilized at that point. NASA has a lot of infrastructure. That's something that's got a lot of press these days. And this is a great way for our partners to not have to recreate all that infrastructure, and also allows us to more fully leverage some of the infrastructure that may not be used 100%. So this has been a real win-win. You can see as of this is just a snapshot of the number of agreements we have with all of our partners at the various centers. There's 28 now. There's been more that have that we've had and have been completed. So probably close to 50 agreements just among our commercial crew partners that have allowed them to leverage our capability and allowed NASA to make those capabilities and equipment available. So that's been a real positive, like I said, win-win in my opinion. Next to last, next slide, is data sharing. Data, that's sort of a catch-all term. It means reports, it means analyses, maybe a test result. We have a lot of data at NASA, from Apollo all the way through Shuttle, all the way to Constellation. A lot of data on human spaceflight, and we can make that available upon request from our partners. To date, our 4 partners, either through CCDev or CCICAP, have made over almost 1,000 requests for data, and we are accommodating those as best we can. It really helps the partners, obviously, because then they don't have to reinvent the wheel. They don't have to redo a test. It helps NASA because it saves us money. If our partners don't have to redo the test, it saves them money. It saves us money. It also helps the nation. The nation gets the benefit of NASA's investment multiple times, not just from what its original purpose was, but we get to sort of repurpose that information for our partners, again, so they don't have to reinvent the wheel, and we can do this in a more cost-effective fashion. I see this, again, as a real super win-win for both NASA and our partners. And then lastly, I won't go into too much detail because this is where Ed's going to talk mostly, is requirements application. We just awarded the certification products contract. For the first time, it gives us a formal mechanism by which we can apply these requirements, disposition them, and give feedback to our partners about how well their design meets our requirements, so that we can be ensured that we get what we want at the end of this partnership phase. And then just to wrap up, I hope I made it within 10 minutes. I didn't get the hook yet, so I guess I'm good. Just to wrap up, I do need to stress that the Commercial Crew Program and our efforts to low Earth orbit, including the International Space Station, are just one part of NASA's overall strategy. We obviously have a deep space exploration strategy. That the programs that are supporting those are the Space Launch System and the Orion Multipurpose Crew Vehicle. So we have a complementary dual strategy at NASA, letting the private sector take a little bit more responsibility for low Earth orbit and International Space Station cargo and crew resupply, while still NASA sort of retains its more traditional role in the deep space exploration part. And again, these are very complementary strategies. We couldn't do one without the other, in my opinion. And what we're talking about today is really just the low Earth orbit piece. So thank you, and I'll turn it over to Rob.
Okay, thank you, Phil. Before I start, I wanted to thank Ed Mango for the invitation to participate here, and also thank our integration team, our PIT team, led by Misty Snupkowski and Bill Hill. They've been an outstanding group of partners and helped lead us through our CCDev 2 effort, so thank you to them. I'm going to talk about Blue Origin and our accomplishments under CCDev 2, and if I can have my first slide, please. You know a little bit about Blue Origin. We've been around since the year 2000. We were founded by Jeff Bezos, the founder and CEO of Amazon.com. We've got a long-term vision of increasing the number of people who can fly into space, and with that long-term goal of making space safe and affordable for more people than it has been in the past. You'll hear about incremental development today. Our incremental development plan includes a focus on reusability. We believe reusability is the best way to get to low-cost access to space and allow you to gain the practice that you need with your vehicles and your fleet to roll those lessons learned from practice into improving your design and lowering the cost even further. We've baselined vertical landing because we believe that's a very scalable approach for going to orbital operations, and vertical landing allows us to recover and reuse our vehicles. And we're starting with suborbital, again, getting to this incremental development fashion, starting with suborbital to prove out the technologies for orbital flight, and then moving on to orbital. We've made significant investment to date. There's some photos on the right-hand side of the chart of our facilities in Kent, Washington, and out in far west Texas that we use for engineering, manufacturing, and development test. We operate the only privately owned launch site in the world, and we've used that for all of our flight demonstrations to date. We have, if you see in the upper right photo, we have our own engine test stand in Kent, where we did development on our own rocket engine, as well as test stands in West Texas that we've used for developing the engine that I'm going to talk about a little bit later today. Also in Kent, we have vehicle manufacturing and capabilities in the Kent facility. I want to leave you with on this chart, we're a strong and growing company. We're hiring. We are adding on manufacturing capability, and it's been a significant growth over the last several years. Let's go to the next chart, please. Again, this chart's titled Incremental Development, and that's the core of our development philosophy. Our suborbital program is in the flight testing stage. We first flew short hop flight tests of a reusable vehicle called Goddard back in 2006. There's a picture on the lower left, and there's videos on our website. And then in 2011 and 12, we started flying our New Shepard vehicle, starting with a vehicle we call PM2. Which we flew on several flights, got that up to Mach 1.2, and the development of our next vehicle in that series in that program is under development right now. In our crew capsule, which is part of the New Shepard program, we did our successful pad escape test in October. That's part of our CCDev 2 agreement, and that's something I'll show you a video about in a later chart. This program is providing lessons learned and practice so that we can develop a low-cost, safe and affordable orbital spaceflight system. And we began development of that on our CCDev 2 contract with our agreement with the System Requirements Review for the orbital space vehicle. And that review took place in May of this past year of 2012. The vehicle is a biconic. It's designed to transport between 4 and 7 astronauts up to the International Space Station, and it weighs about 22,000 pounds with the crew on board at launch. It's designed to fly on multiple launch vehicles, including our own orbital reusable launch vehicle, as well as the Atlas V, and United Launch Alliance was a partner with us under CCDev 2. We worked very closely with them. Our 2-stage orbital launch vehicle has an expendable upper stage and a reusable first stage, and pictures of that are shown on the right-hand side of the chart. And shows a little bit to scale to give you an idea. We believe that the New Shepard system is a subscale version of what we've got under development for our orbital launch system, and that reusable first stage is a key part of that technology. As we've gone into CCDev 2, the decision to get into CCDev 1 and 2 was combined with the significant private investment that came from Mr. Bezos. And the NASA co-funding, we felt, looking at this program that was rolling out a few years ago, was a way to significantly accelerate our efforts. So on the next chart, please, talk a little bit about our CCDev 1 and 2 activities. Our CCDev 1 agreement was a total of $3.7 million. In that period, we developed and demonstrated a composite pressure vessel. We did structural testing, both pressure testing and drop testing of that vehicle. And then we also did some development of our thrust vector control system for our escape system, which was later demonstrated under CCDev 2. Under CCDev 2, our Space Act agreement was for a total of $22 million. And there was 3 projects there. The space vehicle design maturation was to basically refine and develop the design for this biconic vehicle that will fly on top of multiple orbital launch vehicles. We did wind tunnel testing, we did aerodynamic analysis, we did propulsion definition, a lot of requirements for work with Ed and his team. Very, very good partnership on that refined that vehicle so we can take it further to the next steps. The pad escape test was the final milestone in our escape system development project, pusher escape risk reduction project, and I'll talk about that on a separate chart. And then our reusable booster system engine risk reduction test resulted in a full power level test, 100% power level test of an all-new American rocket engine that uses liquid hydrogen as a fuel. So let's go to the next chart, please. We'll talk about this engine, this rocket engine development. We call it the BE-3. It's a 100,000-pound thrust engine. It fits in between where the RL-10 and the J2XR. It uses liquid oxygen, liquid hydrogen as its fuels. And like I said, this is the first all-new American engine that uses liquid hydrogen as a fuel since the RS-68 development. It is deep throttling, it's restartable, and it's fully reusable. And under CCDev 2, we did testing of the thrust chamber at NASA Stennis Space Center E1 complex. The Stennis team has been a fantastic partner on this, and we always intended to continue working with Stennis after the CCDev 2 agreement ended, and our next entry into Stennis is going to be in the middle of February. We ran multiple tests over the full throttle range, going into the teens in terms of percent, and on up to full throttle, which is 100,000 pounds. And the result of this partnership was that we accelerated the development of that BE3 engine by more than a year, because the facilities we've developed under private funding at our West Texas site are not set up to do these types of high-pressure testing. The facility at Stennis is a unique government asset. So getting back to what Phil was saying, access to these unique assets and these unique expertise is a significant benefit to companies like Blue Origin. While we were doing the testing on the TCA at Stennis, we were also testing the turbo pumps, the liquid oxygen and liquid hydrogen turbo pumps at our facility in West Texas. And now we have the engine fully put together, and the testing of that engine is underway at our facility in West Texas. This engine, I want to point out, is fully developed, designed and developed in-house at Blue Origin. We do the analysis, we do the design work, a lot of the fabrication, component testing, and then engine testing, of course. And I've talked a little bit about the development plan, but it's a pretty complex system, and there's quite a few other components to the engine development program. We're going to show a video of our test at Stennis. Before we roll the video, I just want to give you an idea of what you're going to see. You're going to see the engine, the thrust chamber fire from the side. When it ignites, it'll start out at the low throttle setting, and it'll step up in a variety of throttle settings up to full power. The total test duration is about 45 seconds. So if we can go roll the video, we can take a look at this. Again, we call this engine the BE3. It's a liquid oxygen, liquid hydrogen engine, thrust chamber, and full power setting is 100,000 pounds. So, and it's turbo pump fed in its final configuration. But of course, in these tests, it's being run using the pressure of the ground facility. I got to hand it to the Stennis team again. They've done a terrific job, and I think if you had them in the room here, I think what we learned from them and what they learned from us is how to work in a commercial manner, how to speed up development, how to look at those assumptions that you've made when doing things one way, and then looking at when another company comes in and how you can accelerate your progress. We significantly ramped up our rate of testing over the period of this test program, and now it's getting multiple tests a day has been a significant benefit to us. So if we can go to the next chart, please. I'm going to talk about our crew capsule escape system risk reduction project. In October 19th of 2012, we conducted a full end-to-end demonstration of a pad escape system that will be used on our New Shepard suborbital vehicle, but it demonstrates the technologies and the integration required for an orbital system. The escape system is a pusher, and it pushes the crew capsule from the back to a safe distance away from the vehicle in the event that you have a mishap on the launch pad. We think this escape system is analogous to the airbag in your car. It's always there. It's lightweight, it's simple and reliable, and it's something that if you don't use it on a mission, you can just turn around and fly your vehicle again and again with a minimum of inspection. The demonstration here demonstrated, it showed the escape motor firing. It demonstrated our thrust vector control system, which was developed in-house at Blue Origin. The Aerojet provides a solid rocket motor. We developed the thrust vector control system and the aft closure for the motor. The guidance and control, the parachute deployment, the landing, and the recovery. Like I mentioned, this test was conducted with our NASA partners on site at our West Texas launch site on October 19th. And it was the only powered flight test under CCDev 2, so we're very proud of that accomplishment. There's a few pictures at the bottom of the chart, but I want to pull up the video. And before we start the video, I want to just kind of explain what you're going to see. The vehicle is mounted on top of what we call the booster simulator. So it's sitting on top of a structure that represents the upper end of the booster that it's going to be escaping from. That booster simulator is fully instrumented. It's with load cells, pressure, and thermal sensors, so that post-flight we could reconstruct the environments that the booster vehicle will see in an escape, in an in-flight escape, or a pad escape. The vehicle itself, of course, was instrumented. This is a flight structure. You'll notice it doesn't have windows. It also doesn't have seats or life support systems, and That's part of our incremental development program. We wanted to have a flight structure in place, but we wanted to fly this vehicle in this pad escape environment, measure the loads in performance, and then use what we've learned from that to roll into our next version of the design. So let's go ahead and roll the video, and you'll see what we did. And this video is available on our website as well.
1, escape.
Now the vehicle pulls significant accelerations on the escape. It reaches about 2,300 feet altitude above ground. The parachutes deploy and it comes back. It landed within 7 feet of our predicted touchdown point. The winds were light that day, but we still are proud of the accuracy of the predictions we were able to make. Following some stabilization, the main parachutes disreef, and the vehicle descends slowly under the three main parachutes and touches down in the desert.
400. 300. 200.
It was a beautiful day, I might add. So.
100. Touchdown.
So I want to close up with the point. This has been a great commercial partnership. We brought money to the table. NASA brought money to the table, and we were able to do some things that are very useful, very effective, and help Blue to accelerate our progress. It's been a great relationship, and I'm happy to announce that we're working with NASA to extend our Space Act agreement in an unfunded manner, so that we can continue the relationship, continue to learn what we have from NASA, continue to allow them to learn from us, and that's something that we'll be working with them here in the coming weeks, and I'm very pleased about that. So, thank you.
All right, thank you, and thank you, Phil and Ed, and your entire team. It's an honor and certainly exciting to be part of this important new development effort. If we could go to my first slide, our focus on identifying and mitigating risks early in CCDev 2 really ensured we could mature the design to the point that we could accomplish a successful PDR and transition strongly into CCICAP. Our focus was across all of our subsystems to make sure we identified key design and risk drivers, and then perform the analysis and risk reduction demonstration testing that we needed to successfully mature that design. If we're looking at structures and mechanisms, we manufactured 2 iterations of our pressurized crew module, and we're able to do proof and leak tests on it, and also material testing to make sure that the design properties on the as-formed material met all of our requirements. We conducted a number of composite material tests at higher temperatures just to make sure that the material would satisfy all requirements, and early micrometeoroid debris testing to help ensure that our thermal protection system design would satisfy all of our safety requirements. On the landing system, which is a combination of parachutes and landing airbags, we ran a number of 2 parachute drops and a large number of landing airbag drop tests just to make sure that that design was safe and robust in all types of landing environments. Propulsion system, we ran a number of single engine propulsion tests. The service module that we have is a disposable service module that handles not only the launch abort propulsion, but also the on-orbit and entry propulsion, and ensuring that these legacy engines modified to our requirements would perform all the tasks early in the design cycle, really help buy down some development risks. And we also went out to Ames and the wind tunnel test and had a large number of runs and help us build up our aerodynamic database to make sure the vehicle that we're designing could withstand the loads and was also controllable in all flight regimes. On to the next test. Another big focus on our effort to integrate with the launch vehicle. one of the things we did early onto the next page was to bring in the emergency detection system that's being designed and built by United Launch Alliance for incorporation into the Atlas V launch vehicle, and run early testing on an EDS emulator integrated with our software and our flight computer to make sure very early in the software development process that the two systems were compatible or could talk to each other and would satisfy all requirements. We also ran a number of integrated tests between our flight software system and our autonomous rendezvous and docking system, which obviously is a critical piece of this development effort, to make sure that those systems were compatible and would meet all requirements. And a large effort on identifying different options for our cockpit, and then moving quickly at the end of CCDev 2 to finalize that cockpit design with a number of human factors tests in the cockpit to make sure that all of the panels were laid out correctly. We could satisfy, not only normal mission operations, but also anomalies that the crew could expect to encounter. So a lot of work, just making sure we identified those risks and were comfortable moving into CCI cap. Going to the next chart. The real focus of CCI cap is final design maturation and moving into a quality critical design review. And so our focus was laying out a plan that integrated key milestones across all of the different development segments, both spacecraft, the launch vehicle, obviously, which is critical to us, but also production and operations. So across this entire plan, we've got a number of very important and milestones that our team is working on to accomplish. In January of this year, we've got 2 milestones actually. In the next couple of weeks, we'll be releasing our first flight software iteration of our on-orbit configuration, and the team is in the lab now running tests on that, and it looks like that is moving along real well. And then later on this month, we'll also be conducting, actually next week, our landing and recovery and ground communication design review, just to make sure we have the plans and the equipment and the infrastructure we're going to need, not only to communicate from the ground, but also to safely recover and transport the capsule after it's landed. Looking at some of the others, we'll move very quickly into a preliminary design review with United Launch Alliance, one of our key partners on the launch vehicle adapter. That'll be the adapter plate between their launch vehicle and our capsule. We'll be going back and doing more wind tunnel tests. In fact, we've got 5 different wind tunnel test series between March and August of this year, just so that we make sure we have a healthy and robust aerodynamic database so that we can finalize all of our designs. We've got a dual engine Centaur duct test that we've got scheduled later this year. The dual engine Centaur actually has flown 140 successful missions, but not on the Atlas V, previous versions of the Atlas. And so we are going to do a number of component updates. And so that work is understood, but it's something that we want to go demonstrate. We'll have a number of engine test runs again with the Pratt & Whitney Rocketdyne designed service module propulsion system, just to make sure that the final design configuration of those engines will meet all requirements. We'll move in and with our partnership with Mission Operations Director at JSC, who is very integral to our team and adds a tremendous amount of expertise. We'll be doing a Mission Control Center interface demonstration test, moving on with some more production demonstrations. And then in December of this year, our multi-string demonstration of our flight software, which will be a very important milestone. All focused on, in this phase early on right now, we're really focusing on component PDRs, moving very quickly later this year into component CDRs and then into subsystem CDRs. Everything focused on making sure we properly and aggressively mature the design so that we can have a very robust critical design review at the end of this phase. It'll give us confidence that we can move in with very low risk into the qualification and flight demonstration phase. A lot of good work. The team's really excited, and And the first 3 milestones we have accomplished. Moving on to the next page, on schedule, which is very good. The first one coming into CCI CAP was the integrated system review. We had a number of systems that we had some open trades on that we needed to complete going through the preliminary design review, and it was really important to burn down all of those design trades before we moved into CCI CAP. Our team was able to do that, and that really let us snap that baseline design and move into to final design release and start producing those products that we need. The next thing we did, the next milestone, was a production design review. It was important for us early to make sure that we had the right plans, equipment, and infrastructure so that we could efficiently produce the design that we were coming up with. And so getting that early design review and that focus, making sure that the design that we were producing would be manufacturable efficiently was a real benefit, along with bringing in a lot of expertise from across Boeing, both the commercial airplane side and also some of the military and defense that have a lot of production experience, and making sure we're bringing in those best practices was good. Huge focus on safety, obviously, and having that phase 1 safety review completed early in the design process, again, so that you can use that safety analysis to make sure you help inform the design, was really important. And the phase 1 safety review helped us identify all the hazards, the causes, and the controls, just to make sure that we were appropriately embedding safety in all of our designs. And then a lot of work, as I mentioned before, about making sure that we were addressing human factors and that our cockpit was laid out. It's really important to do that early so that we can snap that baseline design and move forward. And so the team was able to do that. On to the next chart. As I mentioned, a lot of focus this phase on making sure we get to final design release and mature the design. The teams, as they're heading to CDR, have a number of, again, risk reduction demonstration tests that they're going to need to get through their design cycle with high confidence. A real focus on making sure we're bringing an integrated system to the table, and so our partnership with some of our really important partners like ULA, Pratt & Whitney Rocketdyne on the propulsion, Aerojet on crew module propulsion, an integrated team focus, making sure we're moving forward. Again, our partnership with Mission Operations, I can't understate that bringing in that legacy experience really helped drive down a significant amount of risk that you would have trying to stand up that capability. So getting that expertise in was critical. And then, one of our real focuses and one of the real benefits has been our partnership with Space Florida and the ability to partner with them on the use of the old Orbiter Processing Facility 3 here at KSC. That partnership has been outstanding, and they've actually, as you can see on some of the pictures on the bottom left, have that building cleaned out now, and they're starting in on the modification process right now. And will be ready to hand over the keys to us this summer. So that's been outstanding to be able to make sure we're able to use not only the skilled resources here in Florida, but also some outstanding infrastructure. So that's been a real bonus for us, and the team's really excited to get in there and start using that. So I'd say, our team has really ramped seamlessly from the preliminary design phase into this final design phase. We're really excited about the work we've got on our plate and the progress we've made to date. Thank you.
Mark? Oh, sorry.
Mike, sure you're finished. You didn't have a video. Hi, everyone. I'm Mark Sarangelo from Sierra Nevada, and I'm really thrilled to be here today to give you an update on what we've been doing with our program. And we have had a major amount of success over the last couple of years, and we're very fortunate to be part of this program and be part of the activity that's going on. I think it's one of the best-led programs that we've been involved with through our history. And we're celebrating our 25th anniversary in space this year and have now over 70 missions with NASA and over 420 missions to space in total. And I have to say that the development of this program really has been extraordinary, because not only has it been well run, but the new ground that we've been trying to cover and put together has been amazing. How much activity has to go on to get this program to be where it is. And I think, as you've heard from all of us, and you will hear from SpaceX in a few minutes, we are moving forward very rapidly, and I think it's a testament to where we are with the program. Our 2012 has been a wonderful year, and I think part of what we like to talk about here, besides the hardware, is the passion that's involved with this. We've been involved with developing our Dream Chaser vehicle now for over 10 years. And when you come see us and when you come be part of our experience, you can see the amount of people who are amazingly passionate. And I have, I believe, the best team in the industry behind this, coming from all over the country to become part of this journey. We've completed now over 20 milestones across our programs. We've been part of this from the very beginning with NASA, and those milestones have been a mixture of very technical and program element milestones with a lot of hardware. And it's part of our belief that hardware development can go side by side behind technical development and program management to make sure that everything gets moved along at the same kind of pace. During this past year, many milestones have been completed, and I'll go through a few of those. But I think as you see them, that really what stands out is that we've gone from being something that is conceptual to being something that is now a full flight size vehicle ready to start its flight tests. And in a very short period of time, that's, in my view, that's one of the greatest accomplishments we can do. If we go to the next slide, please. These accomplishments come from a number of different places, and I want to point out a couple of them, not just because of what they are, but because of what they represent. Our wind tunnel testing was done through the partnership and cooperation of both university. We did some work at Texas A&M, as well as NASA centers, where we did work both at Langley and Marshall. And it's our philosophy, and it's been from the very beginning, that this is a team effort. We now have over a dozen industrial companies involved, 3 universities and 7 NASA centers who are part of our program. And it's this collective group of very talented people, all who have the same kind of passion around moving forward a vehicle that really has made this very special for us. And the wind tunnel testing that we've done in all 3 of the areas really moved the design forward at a pace that we could never have done on our own. And we're very thankful for all our partners and the way that they've interacted with us. Next slide, please. I think when you do something like this, there's certainly a lot of excitement that comes in, but nothing more exciting than when you're actually starting to build the actual vehicle, and when you can put your hands on it and you can see how it comes and gets developed, and you can see it start flying. And this past year saw us developing what we call our ETA, or Engineering Test Article, where we've been able to put it together. And the first vehicle was done to do structural tests and loads tests on the vehicle, and the second vehicle was built to actually start its flight regime. Next slide, please. And we're very pleased to say that that structure was completed during the course of this year and began its early stage testing with a captive carry done in Colorado over Memorial Day weekend of this past year. This is the full-size vehicle, full regime of the vehicle. It's not fully outfitted for orbital flight, but to be able to go from concept to go back into the assembly hangar and see something being built is really extraordinary from my point of view. Next slide, please. And you can see pictures of this. We were very fortunate in Colorado to have some very good backdrops, and we could take advantage of them. And it was really pretty special because we actually did it over Memorial Day weekend. And what you see below this is the University of Colorado in Boulder, where Scott Carpenter lives, and it happened to also be the 50th anniversary of his flight. So we were able to really have a nice tie-in for what we were trying to accomplish. Next slide, please. Other highlights from the year, we did a buffet test model. We developed and started advancing our ECLIS systems. We started doing our simulated for docking, and now have a simulator up and running, and soon to have a more advanced simulator completed. And we've did some very structural and important elements like landing gear and testing. Next slide. I think one of the things that gets lost in this program is how important it is to our country and how important it is to our industry. We're participants in the rollout of Atlantis here as it went through the center in Kennedy. And because in many ways we feel we're the emotional successor to what has gone on with the shuttle, we thank the program leadership a lot. We thank our partnerships a lot. But sometimes what we don't do is thank all the thousands of people in NASA who have worked tirelessly over the years throughout the moon programs and before that, and certainly through the 135 shuttle missions. And we wanted to say thank you to that, and because we feel we've picked up that not only the knowledge from that program, but the emotion behind that program. And one of the things we saw as we came through for the Atlantis is how many people came up to us, and how many people, we had lines going on that people just waited in line to sit and just talk to us. And we feel certainly special about that. But I think what that says is how important this program is to our country and to our industry. People want to believe, they want to feel that exploration means something. And I think as we all have seen, that we feel that that emotion is important to this country. The number of students and kids that came up to us who are going to be the next generation of people sitting on a podium like this, they get inspired by this as we got inspired by it. And I can't say how important that is to our country and to our program. Next slide, please. Our growth has been significant. We've hired many people from all over the industry. People were really talented people. We are expanding our facilities. We're putting on a new dedicated assembly and design and engineering center that will be standing up in the next couple of months. We'll be adding probably up towards 100 new people throughout the country in this next year in 2013. We have 7 NASA centers who are engaged with us, as I said, multiple universities and a number of very significant partners that are part of the program. Next slide. In 2013, we're going to see we think some very major advances. We're going to complete our integrated system and design review. We completed that as part of the CCI CAP milestone. Actually, have completed first 2 milestones under the CCI CAP program, and are about to, in the next 2 weeks, to complete our 3rd. So that program is moving very quickly and very positively forward. I think most evident will be the fact that we're going to start our actual flight test program this year. Our flight vehicle is now being finally assembled and will be moved out to Edwards Air Force Base, where the Dryden Flight Center, NASA Dryden, will be helping us do the work. And we think that's just the right thing to do in many ways. The facility there has been the home of so many tests, including the shuttle test. And we're going to be picking that mantle up and starting our first flight tests here in the first quarter of this year with the vehicle. Autonomous flight tests will happen, and that will be a full drop, and a full autonomous flight. So things are moving very rapidly. Our motor testing is going on in our California facility, and we'll be doing continued rocket motor testing there. And we'll be doing things like our reaction control system and many other hardware activities. So it's going to be a very full year, full of milestones and full of very visible hardware milestones as well. Next. And as I close out in the last minute, we have a very short video, but I wanted to express our appreciation to the press as well. We talk a lot about what's going on. You guys put a lot of effort in here, but it's important that you get the story out that the human space flight is not dead in America. There are at least 4 companies represented here who are working very hard to make that happen in partnership with NASA. And as we go through our budget cycles, it's really important to be able to say for not a lot of money, we've made tremendous progress and are continuing to make tremendous progress. And I thank you for that. If you could run the video now. like to turn it over to Garrett now from SpaceX.
Thanks, Mark. Thanks. So if I can start with my first slide. So about 1.5 years ago, SpaceX started partnering with NASA to work on Crew. And this was really, really important to SpaceX for a number of reasons. First being that the company was founded with the sole intent or sole purpose of advancing the cause of human spaceflight. And so this is really what we're all about. And so having this opportunity to be part of the Commercial Crew program is very special to us. Second reason is that, you know, for well over a year now, since Atlantis came to wheel stop, the United States of America no longer has the capability to launch people into space. And that's something that, that we are not happy about. I'd venture so far as to say that nobody sitting up here on this panel is happy about that. But we're very, very proud to be part of the group, the Commercial Crew program, that's going to do something about that and get Americans back into space. And at SpaceX, we feel a sense of urgency to get Americans back into space on safe and reliable transportation on American-made rockets. And so I'm very happy for that reason to be here today. So during the first program, CCDev 2, we're in a bit of a unique position at SpaceX because we already have a rocket and a spacecraft that is traveling to the space station. In fact, we've gone back and forth to the space station now twice on cargo missions. So we took the approach in CCDev 2 of figuring out, well, what do we have to do to modify this rocket and this spacecraft to not only carry cargo, but to carry people? Now, this wasn't that hard because from the very beginning, we intended to do this. And on our first cargo flight, that vehicle had windows, for example. That's a superficial example, but technically we had built into this vehicle the capability to meet human rating requirements from the very beginning. And so there were still some things we needed to do, technical challenges that we needed to overcome to get ready to carry people. So that's what we focused on in CCDev 2. It was primarily the launch abort system. So we built a new engine, which we call the Super Draco. It's a 17,000-pound thrust hypergol engine. And we were going to use 8 of those to provide basically an ejection capability for the crew to take them to safety in the event that the Falcon 9 rocket is having a bad day. So we developed the engine, we developed a test stand to test the engine, and we developed all the related components. We also worked on all the other things you need to do that people need that cargo doesn't need. So we worked on seats, on spacesuits, on life control systems, how we're going to modify our launch pad, all those different things that we need to do for crew. And finally, we did a bunch of homework, a bunch of analyses to make sure that our designs were heading in the right way. And last, we did a couple crew trials where we brought NASA astronauts in, had them sit in a prototype of the cabin of the Dragon and evaluate it for ergonomics and human factors. So we did all that in that 1 year, and we completed everything back in June of last year. So that's all done. And then we moved on, I'm sorry, in the next slide, there's some pretty pictures of some of those things that we did. You see a depiction of the interior of the cabin, what that's going to look like. We're going to have 2 rows of seating. It's going to be stadium seating. Upper row there is first class. The bottom row is that's the coach, I guess. So that's what it's going to look like on the inside. The picture of the rocket engine there is our Super Draco engine firing on our test stand that we built in just a few months in our facility in Texas. You see some of the modifications we have planned for the tower. In the middle picture on the bottom is some testing we were doing of our carbon dioxide scrubbing for the life support system. And finally, you see a picture of a prototype spacesuit that we worked on. So that was all done and finished back in June of last year. So moving on into CCI-CAP, which we're very proud to be a part of, we basically have 4 main focus areas for CCI-CAP. And this is what we're going to be working on for over another year. And that is to complete the integrated design, to complete the design of both the rocket, the spacecraft, the ground systems, the mission control, all that, to a critical design level, meaning that we're ready to start building and pretty soon flying. So completing through a critical design review is the first goal. Second thing is we're going to do a lot of hardware testing to reduce risk. We believe in testing hardware early and often at SpaceX, and we've already done a bunch of this, and we're going to do even more in the near future. We're focused during this whole period on crew safety. We know this is very, very, I can't stress how important that is. Having strapped into a rocket before, I could tell you that I have a personal emotional reason why I want to build a vehicle that is safer than anything that's flown before by an order of magnitude. And finally, preparing for NASA certification, making sure that we're building a vehicle that is going to meet NASA's needs. So those are the 4 areas that we're focused on. On the next slide, I think I could tell you a little bit more about the detail. This is a whole bunch of different milestones up there, but these are all of our milestones in the space period that accomplish those 4 objectives. And we've already completed the first 4, and we're moving on. The 5th one is coming up in March. Our plan is to get to the point where we can fly to the ISS with a non-NASA crew by the end of 2015. Now that is if we successfully execute all of our base period milestones and our optional period milestones on schedule. And so far we're on schedule. Next slide. So in 2012, what we've done so far in CCICAP, we've completed these 4 milestones: a technical baseline review, a financial and a business review, a system requirements review, and then our most recent one, just before the holidays, we completed our preliminary design review for the ground systems and the ascent part of the flight regimes. So you see some pictures in there, some of those things that went into that preliminary design review. You see a picture of the new engines. We're upgrading the Falcon 9 rocket, and a big part of that upgrade is to be ready to carry crew. One of those things are new engines. That's a Merlin 1D. It finished its qualification testing, and we're moving ahead with that. The next step is to test 9 of them together in a stage. To the right, the picture you see there to the right is wind tunnel testing that we did at Langley, NASA Langley, in partnership with one of these Reimbursable Space Act agreements. And we tested a new shape of the capsule to make sure that our modifications will work well as a cargo Dragon does for coming back through the atmosphere for entry and then ultimately for landing. Finally, you see some conceptual ideas of how we might do displays for the crew, how we would overlay data and video for, in this case, for proximity operations and docking. Next slide. So what we have coming up in 2013, we have a lot on our plate. We're going to be very, very busy. We have a pad abort test review where we're going to go through the test plan in detail for the pad abort test that we are doing at the end of the year. We're going to do a human certification review to make sure that we have a plan in place that will get us to a certified vehicle ready for NASA astronauts to take to the space station. We're doing an on-orbit and entry preliminary design review. So we did already the ground systems and ascent. Next step, we have a second preliminary design review to focus on orbit and entry. That's coming up this summer. Then we move on to the in-flight abort test review. That's the next big hardware test. And then we have a safety review focused on all those products that will go into detail about how we're going to accomplish that order of magnitude safety improvement over any previous vehicle. And then a flight review of our new upgraded Falcon 9 comes in November. And finally, we end the year on a really big high note, which is by doing a pad abort test right here behind us at KSC, where we're going to take this is not a demonstration test, this is a flight-like, full-scale pad abort test for certification as well as risk mitigation. We're going to take a Dragon as flight-like as possible, take it from our pad over at Cape Canaveral Air Force Station, and demonstrate our ability to get away from the Falcon 9 on the pad from 0 altitude and 0 airspeed if we're having a bad day on the pad. So that's what we have coming up in the next year. I want to give you a sneak peek into 2014, if we can show the next slide. So in 2014, we have 3 milestones that wrap up CCICAP base period. And in that period of time, we're going to do a qualification testing of the primary structure. We're going to stress it and bend it and hopefully not break it, but make sure it could take anything that it might get dished at it in flight. We're going to do the final critical design review and prove that we're ready to start manufacturing. And then finally, we're going to end this program by doing an in-flight abort test, meaning that we're going to take a Dragon, again, a flight-like Dragon, full size, stick it on top of a Falcon 9, launch it out of our launch pad right here, and at the worst possible moment, we're going to have that Dragon light up its Super Dracos and fly away and safely splash down into the Atlantic, demonstrating the capability to deliver the crew safely should the Falcon 9 be having a bad day. So in a nutshell, that's what we have planned for CCICAP. Again, we're very happy with this partnership that we have with NASA. We want to see it continue all the way so that in the near future we can get Americans back into space on American rockets.
Ed?
Gee, thanks. As you can tell from our partners, they have been extremely busy. And I think the partnership between NASA and each of these companies clearly shows that we have a very vibrant space industry in the United States, and the space industry wants to meet the goal of getting U.S. capability back into low Earth orbit. I have a few charts to talk about the big picture from the program standpoint and where we're headed, where we're at now, where we're headed. So if I can go to my first chart, this is a chart that kind of shows our program life cycle, and you can think about, well, what's a life cycle? From us program guys, we look at a life cycle from the time we begin a new thought to the time that we are actually executing the mission. And in this case, we really have two purposes of the commercial crew life cycle. One is for a public purpose, and one is also for a specific NASA purpose to get to ISS. You can see that in the yellow life cycle. All of our partners, all four of the folks here today, have all been part of this public purpose, either through CCDev 1, CCDev 2, and now into ICAP. You can see that a couple of them, three of them, are now continuing on into ICAP, and then some of those will then transition into the blue line, which is our NASA purpose, which is certification and services. So by doing this, we really are creating a capability for the nation to use. And as we create that capability, then NASA will become a customer of that service so that we can use this capability to move our flight crew and our astronauts to the International Space Station and continue on with the science of the International Space Station. Well, that's a nice pictorial. Now how do we actually make it work? And that's the next chart. We showed this chart back in August of last year, in which you said, here's our acquisition strategy overall for the program, for the commercial crew program. You can see all the partners here today talked about CCDev 1 and 2 and ICAP, and that's the top portion. We also talked back in August, and I'll re-highlight again, that we have two phases under the certification phase, under the certification effort for our international, for an ISS crew transportation. Phase 1, which I'll talk about that in much more detail here in a minute, is the phase that we're just starting, and it'll be starting in about 2 weeks. We'll then transition to phase 2 in the spring, late spring of 2014. And that second phase I'll also talk about briefly today, and how that phase is really going to take us from all the work that has been done through the development in a partnership with our partners today and with any other new industry partners that would like to come join us to compete for the capability to go get certified for a NASA mission to the International Space Station. And that should be concluded sometime between 2015 and 2017 from an overall schedule standpoint of when we think we can get crew and a capability for services. And then we'll, of course, transition into services once we have a certified system. Today I want to talk a little bit about the next chart, which is our certification products contract. When we awarded ICAP in August, we quickly turned around and said that we need a contract mechanism by which we can talk about requirements, our requirements to get our crew to the International Space Station, our safety requirements as well as our performance requirements. And so the first step of that was this certification products contract. And it was really part of a phased acquisition to get to that certified system. The primary objective of the CPC, as we like to call it, since we like acronyms, is to begin the early critical certification work to meet our set of requirements that we have laid out. It's really maturing key certification products in phase 1. That's what we're talking about in CPC. As those products get matured, then it brings industry and NASA all together to be ready to move into phase 2, which is the actual verification activity and then eventual certification of the system. We're very happy, and we did award these back in December 10th, and I'd like to congratulate the 3 companies that were awarded, Boeing, Sierra Nevada, and SpaceX. They were all awarded contracts for the certification products contract. Each of these is a fixed price contract, all for $10 million or less. There's really 2 sets of products that we will look for in this fixed price arrangement. The first set of products is the initial products of 4 different types I'll talk about here in a minute. And then we'll begin to have a number of technical interchanges with each of the companies to mature those products so they're ready for the final set of products as we move forward. From an overall cost standpoint for the taxpayer, we're going to pay about 40% of the total cost of the contracts in the initial products, which will be due here towards the late spring of 2013. And then we'll pay the rest when the final products are due towards the spring of 2014. This way we continue to work as a performance-based kind of arrangement where work is done. We look at the work, we talk with the partners about the work, and then based on the competency of that work, we then go ahead and will help make payment to our partners and our contractors. The next page talks a little bit more about the details of this certification products contract, in which there are 4 scope products. In the end, we want to get to the end of CPC with a certification plan. That's what we need. In order to get to that end state of a certification plan that both us and our partners can sign up to, we need to have the other 3 products developed and agreed to. Those are the alternate standards. We look at those as NASA has defined a series of standards we'd like them to use. In all of our standards, we say we are willing to talk about and figure out how you would like to meet that intent of those standards, because there's always more than one way to do a job. And we have noticed, as you can see from today's briefing, that each of these have come from very different approaches towards trying to create a capability. So we want to talk about those alternate standards with our contractor partners. We also want to talk about the hazard analysis. From a design standpoint, you design from what can hurt you, and then you design systems to mitigate what can hurt you, and that's called hazard analysis and hazard reports. And we'll work through iterations of those products as we work from the initial phase to the final phase. And finally, it's our verifications and our validation plan. Those verifications are the actual tests you're going to run, and all of our partners talk about the testing they're going to do in the next couple of years, which someday they may say we would like to use those tests as part of their overall verification effort. It will also include additional tests down to the component, tests at the subsystem level, tests at the system level, and tests at the complete vehicle level. And that's what our verification plan that we will work with each of the contractors with and buy into that. And all that comes together to meet a certification plan. That's the products we'll do under CPC. Once we are comfortable with those and our partner contractors are comfortable with that, then we're really ready to go into phase 2. And that's how we plan to approach phase 2. From our requirements, you also got to look at requirements variance process. And we have a number of requirements. All of you can read them online. There are about 300 of them that are our design requirements. There are performance requirements as well as our safety requirements. If you were to actually try to build a vehicle to every word and every I and every T in that requirement set, it probably would be extremely expensive, and it probably would never be able to get off the ground because of weight or power or whatever the issues might be. So what we want to do is we want to talk to each of these contractor partners about if there's anything we need to do to our requirements and variances to those requirements that look at risk. Really, variances are dealing with risk to the safety side, risk due to the cost side, and risk due to the performance side. And we want to look at all 3 of those components from a variance standpoint and talk to the partners and say, do you have other ways of meeting our requirements? Do you have other ways that say we can mitigate the risk, and therefore the requirement, the idea of the requirement is still the same, but the way we want to meet it, the way we want to try to deal with that requirement from a risk standpoint might be different. And we call those variances. And that is really very important that we encourage industry to look at different ways of doing business. As you can see from today's briefing by all 3 partners under ICAP and all 4 partners we have today, that they are looking at this very differently than anything that human spaceflight has done before. And that is good. They also are taking the experiences from human spaceflight that NASA brings to the table and that their teams bring to the table to show that it isn't a new sheet of paper. It's a sheet of paper that has history behind it to see what is good and what is bad about our past and try to improve on that. And that's what we encourage our partners to bring forward in these variances as we move forward. All right, so that's CPC, and that will start again January 22nd and goes until the spring of 2014. And then we talk about our next phase. And our next phase is what we call our certification phase 2. It will cover all aspects of the final development and certification of the crew transportation system. That is to include final design, final manufacturing capabilities, final testing, final qualification, final production and getting into that production, and actual operations. So that's a pretty big deal, and we need to make sure that we continue to partner with our industry partners to move forward so we're ready for phase 2. We intend to not do this, we intend for NASA, my team, not to do this in a vacuum and come up with a plan and roll it out and say, here's your plan, go try to meet it. We want to engage industry in how to evolve getting into phase 2. Because phase 2 is something very different than NASA has done before. It includes, we want to look at different ways of doing business. We want to finalize our plans and encourage involvement from industry. So we're going to be putting out a request for information, or an RFI, about certain questions that we'd like to get some feedback from industry on really within the next week. And we'll be looking for some feedback on that so that it helps us understand how we want to go into phase 2. Phase 2 will be a FAR-based contract, but that's a big picture. Now, how do you go do all the details of that is some of the questions you want to ask about. For example, what type of contract structure, what type of contract type? We have some questions we want to ask industry about and see what kind of feedback we get. We want to talk about how do we approach ISS missions. In the end, for the CPC and for phase 2, it's all about getting to ISS. And so we need to figure out how we incorporate ISS missions into that overall philosophy. And of course, we want to talk about FAA licensing. Because we're in a commercial environment, the idea is ISS is one destination, not the only destination. If that's the case, we need to talk about how we bring the FAA and regulatory agencies into practice with us so that there's an industry out there that isn't just for NASA. It's an industry that's really for the entire planet. And if they're launched out of the United States, then we think the FAA has a very important role in that. And so we have some questions about FAA licensing and how to go do that in enough detail to enter into phase 2. We're going to have a number of industry touch points. The next one will probably be after this RFI, will be in March of this year. Exact dates are still to be determined. And then we're going to come out with a draft RFP probably in the early summer to midsummer timeframe. And that's really important to our industry partners here and anybody else in the industry who wants to participate so they can give us feedback on how we think we're going to go do this. And we'll take that feedback, see what is best from a government incorporation. Again, it's our request for proposal. And incorporate that into our final RFP, which should be coming out in early fall of 2013. The goal there is to have a contract awarded by May of 2014. So you can see that as we get through the base period of ICAP, as we get through CPC, we're now ready to move into this next phase of phase 2 with a contract award. So that's a lot of details about how we're trying to make the activity happen. Of course, a lot of that is based on the fact that there has to be an overall national initiative. And so this final chart I have is talking about how the Commercial Crew Program is really a national involvement. I think all of our partners talked about that. I like the passion that they each had towards trying to create a capability, not just for NASA, but also for the nation. It's a national initiative. It's not just here at Kennedy, although the program headquarters is here at Kennedy. It's not just at Johnson, where the deputy program manager is at, and also I have an awful lot of capability at Johnson that's helping the program. It's not just a NASA thing. It's really a national interest. It's a national human spaceflight activity for the nation. In fact, you can see from this chart that there's really 26 states that have activity dealing with the Commercial Crew Program today. Of those 26 states, there are 56 districts, 56 electoral districts that are a part of our activity that we're doing today. And there's 63 aerospace companies that are involved today. And that's really at the prime and the sub, and going down a little bit down the tier of subs and that kind of thing. Not every sub is listed in these 63 companies. But this shows that this is a national involvement. The Commercial Crew Program is not a single thing, it's a national interest. It's a national thing to get America having a capability to get back to low Earth orbit. That's what we're trying to do. That's what all these companies are trying to do. I applaud each of them for their very unique ways of doing that. My team is extremely energized by the activities that happened last year, and even more of the activities are going to happen this year. The team is extremely, we do a lot of travel, but I don't hear very many complaints about the travel we have to do because we're seeing growth in the American space flight industry. So that's where I'd like to end it, and I'll turn it back over to...
All right. Thank you, Ed. All right, we have a lot of folks lined up for questions today, so I'd like to please ask everyone to limit it to one question and a follow-up. Also, we have social media followers. If you have a question, you can ask your question on Twitter with the hashtag AskNASA. And we'll begin here in Florida. Please wait for the microphone, state your name and affiliation, and to whom you're asking your question. We'll start off with James.
Thank you. James Dean of Florida Today. Phil, I think budget has consistently been stated as the top program risk in its infancy. Now that you have the ICAP plans and milestones and costs all laid out, do you have a better handle now on what the actual costs are to get you to an operational flight by 2017? Can you just give us an update on what budget you anticipate needing after this year to stay on track, or is there still a risk of slipping if you don't get a significant bump from where you're at now?
Yeah, the budget is going to be an extremely challenging topic, I think, not only for this program, but for all NASA programs. I work up at NASA headquarters, and just a couple doors down from me is the director of the ISS program, and a couple more doors down is director of SLS and MPCV, and we all have the same issue, right? We all feel like we could use and need more money to go forward. But we're in a very constrained environment. We're going to have to get what we get. I think to answer your one question about our understanding of the cost, that gets better every month. Now that we have entered into ICAP and CPC, we are seeing a better understanding, a higher fidelity estimates of these crew transportation systems, and that will feed into our budget. We hope to have a budget come out fairly soon. Not sure exactly when that's going to be. The President's budget request for FY14 should be coming out within the next, I don't know when, but several weeks. And of course, there's a lot of activity in Washington, D.C. about that budget. So I can't really say about the budget, but I can say that we are getting smarter every day, as all our partners, about what we really think the costs are going to be. And that is an important factor.
And for the partners, Garrett identified a couple of flight tests coming up in the near term. Could you just, again, update us on your plans for any tests of that nature, or and ultimately, the first crewed flight test if budgets and schedules stay on the track? Yeah.
We, as I mentioned in my presentation, we are expecting to start our atmospheric flight tests here in the first quarter of 2013, and that will be the beginning of a flight test program regime that will continue on through this year and into next year, both autonomous as well as piloted.
Yeah, when you look at our plan, our plan would have first crewed flight in 2016. And when we went and laid out our CCICAP plan, it was very important to us that you follow the mantra of test like you fly and fly like you test. And for us, the big integrated tests such as pad abort, we decided that we needed to incorporate those in our qualification series so that it would be flight design hardware. The large-scale integrated tests, that's naturally where they would fit. And so those would be in our next phase following CDR, so that you can ensure that those larger tests would be done at the flight configuration. So those would be done early, but into the optional period, or phase 2.
Daryl Nail with Fox in Orlando.
Oh, I'm sorry, Daryl. Hang on. Did I cut you off? Go ahead. Okay, go ahead, Daryl.
This question to NASA, how many of the companies up here today will be commercially feasible as you see it, awarding contracts in 2014?
Well, I see all the companies here today are commercially viable as commercial spaceflight companies, no doubt in my mind. Now, who will be ready to compete for what we need in phase 2? I believe that you need to ask the companies. From a NASA standpoint, we believe that industry will be ready. We believe that there'll be more than one, probably 2, 3, maybe others that will be ready to compete for phase 2. But all 4 companies here today are capable and are the leading edge of what it takes to get folks back into low Earth orbit over time.
And a follow-up question to the partners. How does Russians flying American astronauts motivate your company or provide any type of motivation to what you're doing? I think SpaceX answered it.
Well, I could not specifically about the Russians. The lack of a U.S. capability is something obviously that we're not happy about. I flew with, I had Russian partners with me up on the space station, and the partnership is very strong on the ISS side. But I think to be a true partner in the space station, to be an equal partner, we need to come to the table with our own ability to get there, and we don't have that right now. And the fact that we're paying a lot of money, a lot of taxpayer money to the Russians to do that, I think it's $63 million a seat is what we're paying right now to fly U.S. astronauts up to the space station on the Soyuz. When we could be spending that money here in the U.S., yeah, that motivates us.
I think from our perspective, that was the original motivation for us getting into this, was that our belief was that we not only need a U.S. spaceflight program, but from our perspective that the idea of creating American jobs and American industry and moving forward, not just the hardware and the people, but the future of our children who are looking towards what they want to do with their future and how they want to educate. We believe that that's a strong motivation for what we wanted to accomplish. Our target was never other NASA programs or other programs in the United States. Our target was to repatriate that industry back here to the United States, and that's what we're doing.
Yeah, I'd reiterate, I think it's really emotionally and also strategically important that this country is a spacefaring nation, and we're excited to get back to that point.
I'll just add, I think ISS is a great example of international cooperation. So working with countries all over the world is a positive, but if we want to explore the frontier, we have to have a way to get there, and we've got to drive our own vehicle, so to speak. So having that capability for America and for several commercial companies is a real positive. So.
All right, we're going to go to the Johnson Space Center phone bridge now for questions and begin with Irene Klotz. Irene, are you there?
Yes, I'm here. Can you hear me all right?
Yeah, we hear you fine, Irene. Go ahead.
Thanks very much. I have three quick questions. The first for Ed Mango, do you anticipate multiple awards for the phase 2 of the program with flight tests? And for Garrett, if you could give us any update on the root cause of the Falcon 9 engine out. And for Mr. Meyerson, do you see any future on-road back to NASA funding for your company's efforts? Thank you.
See, I think I was first on there. Competition is key for anything that we do in the United States. That's how you get the best price. That's how you get the most innovation. So to answer your question, I very much want more than one company involved in phase 2 because I think it's that competition and that innovation that helps drive all of industry in the right direction and as quickly and as safely as possible.
I guess that was part B, the engine thing? Okay. So we did have an engine anomaly on the last Falcon 9 flight. We had to shut down one of the 9 engines in the first stage. And right after the flight, we convened an investigation group to look at this in-flight anomaly. And that group consisted not only of SpaceX engineers, but also NASA engineers. It was a NASA mission, and so we had NASA participation on the investigation team. That team has worked really, really hard at looking at all the data. We had tons of data. All the sensors kept working after the anomaly occurred, so we had a real plethora of data to sort through, and NASA helped us out with that. And we've gotten to root cause, and we briefed that just before the holidays to our customer, which is Mr. Suffredini, the ISS program manager, and to Bill Gerstenmaier, at the head of human spaceflight at NASA. And right now we're just making sure that they're happy that all of our I's are dotted and T's are crossed, but we do intend to make that information more widely disseminated very, very soon. So I'm sorry I'm leaving you with a bit of a cliffhanger, but I promise you we're going to get you more information on that soon.
Okay. And the third question was whether there's a future on-ramp for NASA funding in the future for a company like Blue Origin. I believe there is. I think during CCDev 2 and CCDev 1, we proved that we're a very innovative company that can provide a lot of value to the government. I think Ed and Phil have seen that firsthand, and the Commercial Crew team. Whether it's with Commercial Crew or other programs within NASA, we always are looking for activities where we can work with the government and help us to accelerate what we're trying to do commercially, and we'll continue to do that. So. I'm optimistic.
Okay, back to the phone bridge, and we have questions, I believe, from Alan Boyle from NBC. Alan?
Hi, can you hear me?
We hear you.
Okay, great. I was hoping to get more details from SpaceX and Garrett about the plans to fly, I think you said, a non-NASA crew by the end of 2015. Could you lay out what that plan would entail? Are these people who would be buying flights, or if you could provide a little more detail, I'd appreciate it.
Sure, I'd be happy to. That is part of our optional. So CCICAP has a base period, but we're also asked to produce a bunch of optional milestones. So all of us, all the partners up here, went ahead and submitted a proposal that was assigned into a Space Act agreement that contained not only up to May 2014, but what we would do beyond that, getting all the way to the point of flying people to the space station. And so we laid out a plan with those milestones that gets us to flying the first test flight in the middle of 2015, and then flying to the space station at the end of 2015. That would be done with a test pilot crew. We were told that because this would be part of the development and prior to final certification, that we were not allowed to legally to use NASA astronauts to be part of that test pilot crew. So SpaceX, we're going to have company test pilots that would fly those missions, but it would be a minimum crew for these test flights. It would not be. We're not selling tickets. Don't call our toll-free number. Those are going to be test flights as part of the final development and test and certification process.
Alan, did you have a follow-up?
No, go ahead.
Alan, did you have a follow-up?
No, I didn't. Go ahead.
Thank you. Frank Mooring from Aviation Week.
Thank you. I have a two-part question. The first part for the NASA guys. Can you give me a sort of total figure for the percentage of support that NASA has given to the development of these three vehicles, I'll say, versus the amount of private funds that have gone in there? And then for the company guys, if you could say whether, given the tight budget environment that we're seeing here in Washington, whether or how much your companies would be able to take up any slack in case the roughly $850 million a year isn't forthcoming from Congress. Thank you.
Yeah, Frank, generally that is proprietary information. It's fairly sensitive how much the companies are putting in, so we don't publicize the percentage that the partners have contributed. We haven't in the past, and we're going to continue to maintain that policy going forward.
But I would add, not from a percentage standpoint, but every dollar that a company puts on the table in this partnership is one less dollar that the taxpayers need to put on the table. So, I'm not going to jump up and down about percentages as much as I would say the fact that it's a partnership and we both bring money to the table allows the taxpayer to get more for their dollar and allows the company to get more for their dollar. And that's what the partnership's all about.
Yeah, that really does provide what we've called skin in the game, and it is a key aspect of the partnership. Again, the percentage is interesting, but it's not. It's more of what the money represents. It represents a commitment on the part of the companies to bring forward some of their own financial resources for the development of these vehicles, and that is critical because we don't anticipate maintaining ownership of these vehicles. The companies are going to maintain the intellectual property, and they're going to own and operate these systems, and we think it's appropriate in that kind of situation for them to bring money to the table, which all of them are doing in pretty substantial fashion, even though we don't quote percentages.
And let's see, the second part of your question, Frank, I think asked about whether we companies would be willing to commit more if the NASA funding was lower than the $850 million request or plan. You know, I'd say, you know, when we look at our plan, I think we've put together a robust but affordable and aggressive. And whether the company really could contribute more, I think you have to wait and look at the true market assessment at that time and see how much the market has matured, and then look at the ability of your company to invest more and whether you could get a return. So I think you just really have to wait and look at the market emerging at that point.
I think from our perspective, we are contributing significantly to the program, and one of the things that a reduced budget would do is affect schedule, probably for all of us. And schedule is highly important here because we are targeting to get the most utilization out of the ISS as possible. So I think that the downside of this would be that while the program might maintain itself and we can continue to do the work that we're doing, it might take longer to get there. And that's going to have an effect on the really valuable work that's being done on the station.
So just to follow up, I guess this is kind of the same thing. To try to speculate about what would happen should funding be less or you know, different things occur with the federal budget. You know, life is vexing enough without entertaining hypotheticals. So I don't want to go out on a limb and try to cover all the possible permutations of what might happen. But I could tell you that SpaceX, like I said, human spaceflight is our reason for being. We are in this for the long haul. There will be impacts to cost and schedule. It should funding dry up, but you know, we're going to get there eventually.
Okay, next up is Dan Leone from Space News.
Hi, question for Ray at Blue Origin. Ray, would Blue Origin be interested in trying to get a CCTS Phase 2 contract? Because those, I've been told very clearly that those are full and open competition, and that anybody who has a space transportation system that meets the requirements is welcome to apply. And of those who haven't gotten one already, I would hazard to say that Blue Origin probably the furthest along. Is that work that the company is interested in, or would you give that a pass?
I can't really say until I see the draft RFP, and that hasn't come out yet. So what I know about it is what I've seen today. So it's a little too early to say, Dan.
Any follow-up, Dan? Okay, let's move on to Mark Matthews from the Orlando Sentinel. Mark?
Hey guys, can you hear me?
Yes, we hear you, Mark.
All right, this question's for John, similar to the one that was posed to Garrett a little bit earlier today, talking about that 2016 test flight. Would this also be a non-NASA crew? Would it be a NASA crew? What type of crew size are we looking at? Where would it go? Can I get some more details about what you guys are planning there? Thanks.
Yeah, sure. Part of the requirements of CCICAP was to culminate with a crewed flight test that had non-NASA crew. So like Garrett, we have a crewed flight test planned. Ours is in 2016 with Boeing crew. There would be a 3-day flight demonstration test.
Okay. Next on the line is Tariq Malik from Space.com. Tariq?
Thank you. I also had a crew-related question for these new spacecraft. I'm just curious if each of the members of the panel could give us just a glimpse into your test pilot selection process. Do you have test pilots on staff? Garrett, I would imagine you'd be on that list for SpaceX. How are you training and merging that with the experience that you get from the astronauts that you work with as well? Thank you.
Well, I'll start. I mean, we have 2 former NASA astronauts on staff, and they help us in a lot of different areas, bring a very unique perspective. But I think the incremental development starting with suborbital allows you to really approach this in a different way in terms of training your flight crew and in a space-like environment, but not a fully orbital environment. And not unlike what NASA does with high-performance aircraft. So this is an approach we'll take to our development and preparation for orbital flight.
Sure. And one of our key acquisitions was Chris Ferguson, who was the last space shuttle commander. So he is on our team and responsible for crew and mission operations. And he is defining, not only the crew requirements but also the selection process.
From our perspective, our flight program is being run by Steve Lindsay. Steve is a 5-time shuttle pilot and former chief of the astronaut office. And because our vehicle is a lifting body piloted vehicle that has very direct similarities to the shuttle, there is a significant pool of people who have experience in that regard that we can draw on.
And at SpaceX, we're just starting internal discussions about how we're going to select crews for those first couple flights. So I don't have a definite answer for you, but I can tell you that since you made it personal, I did not come to SpaceX specifically with the number one priority of going back into space. If that was my number one goal, I would have stayed at NASA in the astronaut office and had opportunity to fly again to the space station. So what's important to me is not that I get to be the guy that flies on this vehicle. What's important to me is that I can look myself in the mirror, look at my wife and my son, and say to them that the risk is acceptable for me to fly. So that it's not important that I go, but I have to be willing to go, because I'm not strapping somebody else into it if I'm not willing to strap into it myself.
If I could add, though, I think everyone here, if I know the people that come to work at commercial space companies, I think there's probably no shortage of people that will want to sign up and fly on any of our vehicles in those early flights. So.
Okay, next online, and I apologize if I get your name wrong, but is it Veronique LaCapra from NPR? Sounds like somebody is not muted on the phone bridge. Veronique, are you there? Okay, let's move on to Ed Grausberg from Flight International. Ed?
Okay.
How about,
sorry, no questions at this time.
Okay, I'm sorry, who was that?
This is Veronique, and I have no questions at this time. Thank you.
Okay, thank you, Veronique. How about Ed Grausberg from Flight International?
There's no Ed, but there is a Zach. I have no questions at this time.
Oh, okay, Zach, welcome. Go ahead. Oh, no questions? Okay. Michael Belfari from Popular Mechanics. How about Ken Kramer?
Hi, thank you. Yes, I'm here. First, good luck to everyone in getting American astronauts back in space as soon as possible. I have two quick questions for Mark and for Garrett. Garrett, please, can you tell us, you talked a little bit about the resolving the engine problem, hopefully. Are you aiming for a March 1st flight of the next mission, or what is the target? And for Mark Sarangelo, talk a little bit more about that flight test article, what that would involve. Do you intend to launch that on an Atlas, and how close would it be to the actual vehicle? Thank you.
So yes, I'll go ahead first and say, as far as our next launch of the Cargo Dragon to the space station, yes, it's on schedule for an early March launch here out of Cape Canaveral, and we don't see right now any issues that would hold that up.
Thanks for the question. Our flight test vehicle is a full-size vehicle. The outer mold line and the perimeter of the vehicle is exactly what we would be sending to orbit. It's not outfitted for orbital flight. It is outfitted for atmospheric flight test. And the best way to provide analogy, it's very similar to what NASA did in the shuttle program with the Enterprise, creating a vehicle that would allow it to do significant flight tests whose design then would filter into the final vehicle for orbital flight.
Ken, anything else?
Oh, well, I could ask Boeing a question if there is time. How close are you actually to cutting metal? And for Ed Mango, why are NASA astronauts not allowed on these test flights? Thanks.
See, was the first question about when we're going to cut metal? Who was that to?
I think that was for Boeing. First
Okay.
question on when we're cut metal. I think our first piece of flight design hardware will be delivered to KSC in the old OPF-3 within 5 months.
See, your other question was about NASA crew. And so at this point, what I'll say is under ICAP, if you remember a chart I had the two circles. One was public purpose, one was a NASA mission purpose. Under ICAP, that is really the transition, that is really mostly public purpose. And because we want our industry partners to develop a capability that they can use to go to destinations in low Earth orbit, we would like them to get to a point where they're ready to put their crew on their vehicle at their risk. And so it changes the dynamic a little bit when normally under a contract, the contractor comes forward and says he's ready to go fly, but it's a NASA individual that's going to sit on a rocket, so it becomes a NASA risk. What we did is we flipped it around under ICAP. It's not what we're going to do long term under phase 2, but we flipped that around under ICAP and said, we want to know when you're ready to fly your crew and put your people at risk. And that then becomes something that we were able to evaluate under ICAP. So I would say also, I think Garrett said it very well, in the end, all of our partners want to fly safe. They're not going to take any shortcuts on flying safe. They are going to try to figure out how to go do that the best way they can. And so all of us have the same initiative, and it doesn't matter who's sitting on top of the vehicle. It's a person, and that person needs to fly safely and get back home to their family. So that's the mission of all our folks on this panel and all of our industry partners, is to figure out how to get someone to fly. It doesn't matter if they're wearing a blue suit or a company suit, how they get back to landing and go back to see their family.
Okay, and I believe we have one more on the phone bridge from Eric Good. Eric, are you there? Eric? Okay, well, we're back here. Before we pick up any follow-up questions, we do have one that we received via Twitter on Ask NASA, and it's from Pat Host with Defense Daily. What are the specific safety requirements and standards that have to be reached for certification?
Well, let's see, this is Ed Mango. How I would answer that is if you look at our web page, and we can get you that afterwards, it has all of our requirements listed. There's roughly about 300 of them. They are safety requirements. Examples would be we have to be able to fly with a fault tolerance scenario that says if you were to lose a particular system, you have a backup system in order to get the crew through the rest of the mission safely. That would be the kind of requirements we have. Another one would be that during an abort, we have to be able to get the crew back to the surface safely. I think in the video that Sierra Nevada showed, they said no black zones. That's what we like to call it, I guess, in vernacular. But in reality, it's want to make sure that we can get the crew back to the surface and survive that all the way down to the surface on any abort scenario. We also have other performance requirements, which is we need to get the ISS for our mission. We need to provide 4 crew to the International Space Station. The vehicle needs to be docked to the International Space Station for up to 210 days and be able to leave at any time in order to get back home, either for an emergency to get back home or at the end of that particular mission. So those are the kind of requirements. Now again, there's a couple hundred of them, and you can go online and get all those at our website. And all those have been defined, they've all been baselined. All the companies have them. They've had them since August. And so everyone is working towards the same set of requirements, and we don't expect to change them. We went through a great extent of trying to make sure we understood them, and we gave them out to industry, and now we're moving forward. And so that's what we expect the companies to try to meet, and when they have a better way of doing it, then they'll bring forward their variances, and we'll talk about those.
Okay, and we also just received a Twitter question from Alan Boyle from NBC, who was with us on the phone bridge. He wants to know, does Sierra Nevada have a crewed flight plan? They're planning suborbital flights first, question mark.
Yes, we do. Our vehicle is what we like to call optionally piloted, which means it's fully autonomous and fully piloted from its design. And so too does the flight test program. alternate between autonomous flights and crewed flights, and we will be going through the suborbital regime to get to orbital flight, and we will be doing that in both autonomous as well as crewed versions.
Okay, thank you. All right, we're back here at Kennedy. Do we have any follow-up questions? Seeing none, I want to thank you all very much and turn it over to Mr. Mango for some closing remarks.
Okay, thanks. And I definitely want to thank everyone for coming out to Florida. It's probably the warmest day I've ever seen in January, so thanks for coming to Chamber of Commerce Florida Day. I would say that you know, the couple questions about crews and who they are, and I think I tried to answer that earlier about, you know, to us, it does matter who's on top of the vehicle for a particular mission. When we're in our test flight phase, whether it's under ICAP, it will be crews from the companies. Under phase 2, it will be probably a combined crews between what NASA needs as well as what the company might want to do, and we'll have to go talk about all those details. But in the end, this is a joint effort between our astronaut corps and the astronauts or the crew members that the individual companies might be hiring. And it's that joint test plan that would get us to an end state. It isn't just one or the other. If anyone has developed aircraft in the past, you know that it's military pilots as well as pilots from the companies that do the flight testing. And so we expect that same kind of approach as we move through this overall process of trying to get developed. I'd also say it is important to talk about those blue suiters or company pilots that are flying the vehicles. But I would also say, just like in STS-1 in 1981, there were 2 pilots flying that vehicle, 2 test pilots. They took an awful lot of risk on that particular mission, but there were thousands, if not tens of thousands, of people behind there to make sure the vehicle was going to fly safe and the first test flight was going to be successful. It's no different than in this generation of human spaceflight endeavor that we're proceeding with. There'll be a couple people that are sitting on top of the vehicle, ready to fly the vehicle, but there'll be hundreds, if not thousands of people that are engineers, technicians, mechanics, quality folks that are behind the 2 people or 4 people that are sitting on top of the vehicle to go fly, that are going to make sure that the vehicle is as safe as possible to go fly. That is an American endeavor. That is a national interest. That is a national involvement to go make this happen. It's not just about the 2. It's about the hundreds of people that want to see America get back into space and have a transportation system to do so to low Earth orbit. Thanks for coming today, and thanks for listening. And y'all have a good day.
All right, thank you. And a reminder, you can stay up to date on the exciting progress of the Commercial Crew Program in several ways. On the web at www.nasa.gov/commercialcrew, on Twitter @commercialcrew, and on Facebook @NASA Commercial Crew. Thank you once again, and have a great day.